Hi everyone. In the previous video, we have discussed about what is vehicular network architecture and why we need this, and we have also discussed the major components presented in the vehicle network architecture, and finally we have discussed the basic architecture. And in this video, we are going to see about what are the communication hierarchy presented in the vehicle network architecture, and then their advantages, working, and finally the applications. So let us now look at the communication hierarchy. So this is the basic communication hierarchy presented in the vehicle network architecture. So different vehicle communication protocols are mainly used for different requirements. At the lower level, we are having a LIN protocol, so which is also called as local interconnect network. It mainly supports relatively low speed communication purposes. So that may be up to 20 kilobits per second. So as shown in the figure, so it is mainly suitable for body electronics such as windows, seats, mirrors, and lights. So for these applications, we are using LIN protocol. And the next thing is CAN, that is controller area network, which has been used up to 1 megabits per second. So it provides a medium speed communication. And it is widely used for real-time purpose such as engine, ABS, and transmission. And the next thing is FlexRay, which has been used for the support of higher speed communication, and it may be used up to 10 Mbps, which has been shown in the figure. So the major applications area of FlexRay is it is suitable for safety critical and high speed applications. So including applications such as steer by wire and brake by wire. And the next thing is at the top, which is nothing but the automotive Ethernet. So that provides a very high bandwidth, which shows up to some gigabits per second range. So it is suitable for high bandwidth applications such as ADAS, camera, and infotainment. So this is what presented in the communication hierarchy. So as we move upward, the communication capability and bandwidth increases, allowing the network mainly to support increasingly demanding applications. The next thing is advantages of vehicular networking. The first, it reduces the wiring harness and vehicle network, and then it improves reliability and fault tolerance, and it also enables the real-time and efficient data communication, and further it makes vehicle diagnostics and maintains easier. It also enhances safety, comfort, and vehicle performance. And finally, it supports future expansion and also OTA updates. So, therefore, networking is essential part of modern vehicle architecture. And next comes the real working area, that is the working example of working of vehicle network architecture. So here the example is given for braking systems. So how it exactly works. So let us consider an example. Suppose the driver presses the brake pedal. The first step is the detection of the action by the brake sensor. And the sensor detects an electrical signal corresponding to the driver braking action. The signal is received by ECU, that is ABS, so anti-braking systems, anti-lock braking systems. So this processes the information and it sends an appropriate control message through a CAN bus, that is controller area network bus. So the communication network bus allows this message to reach the required systems. The brake actuator receives the command and finally performs the required physical action. Thus, the vehicle wheels are controlled safely and efficiently. And here, the process has been given. First, the driver presses the brake pedal, and the brake sensor detects the action. After that, the ABS ECU receives the signal, and this sends the message over CAN bus, where the brake actuator receives the command and the wheels are controlled safely and efficiently. This is how the braking process works. This is a simple example of how sensing, processing, communication, and actuation work together. So, notice that the communication network is an important link between the ECU and other vehicle components. This demonstrates why real-time and reliable communication is essential in automotive systems. If communication is delayed or unreliable in a safety-related application, the vehicle's operations can be affected fully. Therefore, the appropriate networking protocols are selected according to the requirement of each vehicle subsystem. And the next comes the application area. So where the uh, application where the process works. So it mainly works in the engine management, where the ECU communicate with sensors and actuators to monitor and control engine operations. And the next thing is anti-locking braking systems. And the third one is airbag systems, where communication between sensors and airbag is important for vehicle safety. And the next thing is the power steering and climate control. So it is also used for infotainment systems, including displays, audio, and navigation. And the another most important application is adaptive cruise control. So it uses information from sensors and control systems to maintain a suitable vehicle speed and distance. For speed and distance, we are using adaptive cruise control. And the next thing is it is also used in electric vehicles. So modern electric vehicles contain several electronic control systems that needs to communicate with each other. Another growing application is autonomous vehicles, that is automatic driving, self-driving cars. So these vehicles require communication between sensors, ECUs, ADAS systems, and other vehicle components. And finally, it supports vehicle diagnostic that allows faults and systems conditions to be monitored. So, from engine control and braking to infotainment, electric vehicles, autonomous vehicles, and diagnostic communication networks are now fundamental to modern automobiles. So, it is a major fundamental for modern automobiles. And finally, we can just summarize the vehicle network architecture. So, what we have learned is first thing we learn the need for vehicle networks and the major components. So, the major components are ECUs, sensors, communication networks, actuators, and gateway ECUs. And after that, we have studied the architecture and communication hierarchy that includes LIN, CAN, FlexRay, and Ethernet. And then we discussed one example with braking system, and finally with the applications. So that's all about the vehicle network architecture. And the next video we will discuss about the Ethernet, TCP, UDP, and IP. So these general purpose networks and protocol suites. And thank you for this for watching this video. Thank you.